There are many products that cannot be easily defined using the standard SolidWorks tools, and these will require more advanced modelling techniques. SolidWorks has everything you need to improve your designs, so let's take a look at some of the more interesting features. One of the first tools you will come across is lofting, and this tool has come from the shipbuilding industry, where a shape is defined by taking slices through the geometry. SolidWorks can create geometry in the same way, with the engineer creating multiple sketches and morphing a shape between them. This shape can then be further enhanced with the use of guide curves and/or tangency conditions. In the example of this boat hull, we have used multiple surface lofts to define the various chine lines and then blended the main hull together with fillets. The bow is created by extending the natural surface to meet the centre line of the hull. These surfaces are then mirrored and filleted to create a smooth shape, with any remaining gaps plugged using the surface fill command. Continuing the nautical theme, let's have a look at this paddle designed for stand-up paddleboarding, and hence its long slender shape. The two interesting areas are the handle and the blade, and we'll start with the handle. Although this shape looks very organic and complicated, the actual majority of the shape has been created with a single loft, but this time it is the guide curves that are controlling the way a single elliptical profile is morphed into a single point at the top. With these curves, and with the selected start and end tangency options available, we can create this shape very simply into one comfortable handle. In this example, we have also used them to create a solid shape rather than an individual surface. When we look at the construction of the blade, then we will see it has been created by using individual surfaces. This method is useful when no single command will give us a good start at a model. Instead, we can create separate points of reference and then slowly patch together our final design. We've used guide curves again, but we have merged multiple guide curves to create a single composite curve that defines the external leading edge of this blade. With the external boundary created, we can construct the rest of the model by patching in the remaining surfaces. Typically, this is from lofting from a new sketch drawn on the centre line of the paddle to the newly created edge running around the outside of the blade. This needs to be repeated underneath, of course. With the blade being symmetrical, we can mirror the faces across the centre line to get an idea of the finished product. Although we're working in surfaces, generally the goal is to construct a complete watertight solid shape. So to do this, we must fill any remaining gaps. In this case, it's the end of the paddle that needs to be filled. We can then knit all these surfaces together and form a solid geometrical shape. The rest of the design is now finished off with regular features. I have briefly described both solid and surface modelling. However, many products might need a combination of these methods, a hybrid method of design, and that is easily achieved in SolidWorks. This water bottle is designed in exactly that way. We start with a simple revolved shape, but then remove one of its faces. This turns this into a surface model. We can then create additional surfaces to fill the hole with something new. I offset the original surface and then use our powerful trimming tools to create an equal gap around that opening. This is then filled with a boundary surface and filleted. The fillet tool itself has many options to get you just the result you're looking for, such as constant or variable fillets, as well as plenty of choices regarding the fillet profile like asymmetric, continuous curvature or constant chord width. SolidWorks also has plenty of freeform tools. Here we can add a finger groove directly onto the recessed area by pushing and pulling that surface directly, with all the downstream features updating with these geometric changes. We can also evaluate our design modifications using the tools such as zebra stripes and curvature. I hope you've enjoyed this brief overview of some of the tools used by the millions of SolidWorks users worldwide. Please get in touch if you would like more information. Thank you.